Have you put your data to work? Brookhuis Applied Data Intelligence offers a series of e-learning lectures on the operational quality of clean rooms. The goal is to learn to acquire data and to put these to work. This is a presentation on particle deposition data. Our presentations will be on air cleanliness, surface cleanliness, measurement methods and data, on how to set up a risk assessment and set requirements for air cleanliness and surface cleanliness, and, of course, monitoring particle deposition rate. An overview can be found on our website www.brookhuis.com cleanroom. A clean room is a controlled, clean environment. It is used to keep a vulnerable surface clean. It is an environment where the introduction of particles is limited, and particles which are introduced into the air are removed by ventilation with filtered air and by cleaning. Particle deposition. Particles that cannot be removed by ventilation deposit on all surfaces. The deposition depends on the particle size. Particles can also carry microorganisms. The majority of particles larger than 25 micrometers cannot be removed by airflow, and all particles larger than 50 micrometers will not be removed by airflow and deposited on all surfaces. The deposition of particles increases the surface cleanliness, the surface contamination, until the surface is cleaned again. Here you see a diagram where you see a product on the table and you see a person. In a clean room, people are the major source of contamination. A person scratches particles, skin particles, and microorganisms. In a clean room, the air around this person is mixed with clean filtered air so that the resulting concentration of particles in the air reduces. And the airflow removes all particles which are airborne out of the clean room. But particles which are large and cannot stay in this airflow, they will deposit on all surfaces. The size of the particles that will deposit is depending on the time airflow is inside a clean room. So when the ventilation is high, then the time a particle gets to the deposit is much shorter. You will deposit larger particles inside the clean room. Particle deposition. On the left, you see a diagram where you see the relation between particle size and deposition of particles. When we look at particles larger than 1 micrometer, you can see the particles which deposit by gravitation or by impaction. When you look at the particles smaller than 1 micrometer, we come into the area where particles are moved by Brownian motion, by diffusion, and they also deposit on surfaces. When we look at particle deposition in clean rooms, we focus in relation to operational quality, we focus on particles larger than 1 micrometer. It is also important to look at airflows around objects. If you get turbulence around the object, this turbulent airflow can give the particle a certain momentum by which it can hit a surface. That way you can have particle deposition not only on horizontal surface but also on vertical surface and even underneath a horizontal surface. Particle deposition rate. That's the number of particles larger than a particular size d in micrometers per area per hour. A particle deposition rate level is independent of particle size and gives you a general level of particle deposition in the clean room. It's expressed in number of particles per area in square centimeters, square decimeters or square meters per hour. The number of particles that the deposit is proportional to the particle size. The particle deposition rate can be found by dividing the particle deposition rate level by the particle size d. Particle deposition depends on the particle concentration in air. but also particle deposition will cause an increase of particles on surfaces and by that have an impact on surface cleanliness. Particle deposition rate is in fact the product of particle concentration in the air times the deposition velocity. So you can say that particle deposition rate is the concentration of particles times the particle deposition velocity, but it's also equal to the change of surface cleanliness divided by time. Products can be contaminated by particles through deposition. So the particle deposition rate determines the risk of product contamination, while in fact risk is severity times the likelihood of contamination. Severity means the consequences of contamination, so that could be high if particles are large and could be lower when particles are small. And the likelihood of particles depositing onto a product is in fact related to the product area and the time the product is exposed. So the number of particles larger than D is in fact the particle deposition rate level times the product area times the time of exposure during operation divided by the particle size, by the critical particle size D. You can also turn it the other way around and you can also set requirements for the particle deposition rate level. In that case, the particle deposition rate level is the number of acceptable particles for a certain particle size related to the number of acceptable particles. So that way you can say I accept a number of particles which I don't want to have at all, so that will be a very low number, or I accept a particle of a smaller size and it can be a little bit higher number. Well, this number you divide by your product area and the time of exposure. And that way you can get your particle deposition rate limit. Particle size. Particles are three-dimensional objects. They are not a sphere, but they have all kind of odd shapes. So it's very difficult to determine the particle size just with one number. So you have to make an agreement with that. And when you look at particles on a surface and you look through a microscope, you see the silhouette of a particle. And when we talk about surface cleanliness, we take the largest size of the particle, also called the ferrite diameter, because the ferrite diameter is the dimension of a particle when you take it in between a caliper. In my presentations, I write the particle size as a big D when it's the length of a particle. There are other ways of measuring particles like a particle counter. They look at the equivalent diameter of a particle, and that I often write with a small d. So, the particle deposition rate determines the contamination risk. The risk of surface contamination of your product, your process, your patient. And it depends on the contamination sources, your cleanroom installation, and the cleaning program. So there are three factors which you can get information on if you monitor your particle deposition rate. And I'll explain that later. Particle deposition monitoring. So now we're talking about acquiring particle deposition data. This data gives you information with respect to your contamination risk, how much is my product at risk, but also with respect to my cleanroom quality, how good is my ventilation, how good is the discipline of people working in the cleanroom, how good is the cleaning program. The time of deposition correlates with the activities. So if you do a real-time particle deposition monitoring, you can see when you have a high number of particles depositing on the surface and when it's low. Typically, when there are no activities, the particle deposition rate is low. When there's a lot of activities, you see it will be high. You can also look at what is the real particle deposition rate compared to the limit you've set from your risk assessment of your product. Particle deposition rate for small particles is influenced by the ventilation removal efficiency. Particles a little bit larger, let's say between 40 and 100 micrometers, are influenced mainly by people. The number of people, the type of garments they use, the way they behave. So in general, the cleanroom discipline. And larger particles, larger than 100, the numbers are low, but if you don't clean, the numbers are increasing, and more you'll see them in the particle deposition measurements. So measuring particle deposition and looking at particles larger than 100 micrometers gives you information on the quality of your cleaning program. There are two diagrams. One diagram shows the number of particles larger than 15 micrometers that are deposited on the sensor or on the witness plate. You can see that in time this deposition is very irregular. Sometimes you have a high number of particles depositing on the sensor, and sometimes it's low. On the right hand side we have a diagram which shows the distribution of particles. It's the differential distribution of particles in numbers, that's the blue diagram, or particle area coverage. So large particles, they cover a large area, and of course you can see with the bar on the right hand side that this is high. That means that the particles have a high area coverage or a high obscuration. In the previous slide I showed you a bar diagram which in blue gave the differential distribution of the number of particles versus particle size. The differential distribution can be recalculated into a cumulative distribution, which is shown in this graph. This is the cumulative distribution of the deposited particles per area per time. The tangent of this graph shows you the particle deposition rate level. There are three areas colored: the area between 15 and 40 micrometers, between 40 and 100 micrometers, and larger than 100 micrometers. These are the three main influences with respect to cleanroom quality. On the left side is the impact of the ventilation system. In the middle, the impact of cleanroom discipline, number of people, garments they use, and on the right hand side the influence of the cleaning program. So this was in short a presentation on particle deposition data. In other sections we'll go into more depth of the use of particle deposition data. I explained to you that the data can be used to either look at the risk of contamination of your product, or you use it to look at the quality of your clean room. You look at the impact of cleaning, discipline and ventilation. I invite you to come to a next session.